Hi everyone. So we did a completion of square to express this quadratic in the standard form. And as we said before, that in doing so, we are setting it up so we can have a better understanding of what this looks like. So here's how that works. First, to draw the graph, notice that what you can do is what are the transformations here? So the transformations, right? That's going to be, you start with x squared, then you go x minus 3 squared, then you go 2 times x minus 3 squared, and then you go 2 times x minus 3 squared minus 5, right? So this is a right shift by 3, this is stretch, and this is downshift by 5 of the function x squared. So that means if you start with x squared, you move it to the right, so this is 3 comma 0, you stretch it out, actually this should be a shrink because you're making the output twice as big, right? So this should be shrink, and then you're moving it 5 units down, so somewhere here. So after you make the rough sketch, what you have is that this point, this point because you took 3 comma 0 and you moved it 5 down, so the vertex. The vertex is at 3, negative 5, and that's what your graph looks like. Now you need to figure out x-intercept, and maybe let's draw it so that there is a y-intercept, and we just have to figure it out. Now figuring y-intercept is easy, right? What is y-intercept? Y-intercept is when x is 0. So when x is 0, what is y? It's 2 times 0 minus 3 squared minus 5, which is 2 times 9 minus 5, which is 13. Okay, so the y-intercept is at 0 comma 13. The x-intercept is when y is 0, right? So you're trying to solve 2 times x minus 3 squared minus 5 is 0, or 2 times x minus 3 squared is 5, x minus 3 squared is 5 over 2, x minus 3 is plus minus square root of 5 over 2, and x is 3 plus minus square root of 5 over 2. Now over here, after you do these, you may have to change the graph a little bit, right? Because what is happening is, the vertex is over there. The y-intercept is positive and big, so it's somewhere here, right? 0, 13. Now if you look at the x-intercept, 5 over 2 is 0.5. Now the square root of 0.5 is surely less than 3. So even if you subtract it, it's still going to be positive. So this means both the intercepts are positive. Another way to think about it is, you can't really have an x-intercept here because then it would have to return, and that's not how parabolas look like, right? So the x-intercepts are somewhere here, and so that is going to be your graph. So you can just write these as x1, x2, where these are x1 and x2. If it's a whole number like 3, 5 or 4, 6, you can always write that down, but if it's complicated with square roots, you can indicate it in your work, and you can just label those points by their names on the graph. All right. So once you have that, that is, you have the graph. The second thing to consider here is the max and min value of this expression. Okay. So a little background on max and min values. As always, we start with the simplest scenario, right? We start with the simplest things that we know. Now, one of the simplest thing about max and min that we know is that squares, right, of numbers are always positive or 0. Now, when you square a number, a real number, it can never be negative. So this means that the minimum value a square can take is 0. That's very, very important. Okay. And that minimum value happens exactly when the number you're squaring is 0, right? So for example, the min of x squared is 0 and happens when x equals 0. Now, if we go back and look at the parabolic shapes, for parabolic shapes, there's always a vertex, right? And the vertex, depending on the parabola being upward or downward facing, is a min or a max value, right? It's the lowest point or it's the highest point, right? So the vertex of parabola is the min or max point always. Okay, so let's look at this expression. So a times x minus h squared plus k. The only thing we can say for sure is that this has a minimum value of 0, right? Which means that we can say that if this is my function, right, then this will be minimum if this is true, right? And when does that happen? This happens if the x minus h squared is 0 or if x equals h. And when x equals h, f of x equals k. So the minimum value is k and occurs at x equals h. And it's fairly obvious from here, just from transformation, right? This means it's moving h units to the right and k units up, which is also the vertex, right? So the vertex is at h comma k, which says the exact same thing because that is the input or the x value and that's the output or the y value at minimum. And the same logic follows for if you have a downward facing parabola, which happens if your coefficient for the x squared is negative. Okay, so these are all the same ideas. The vertex of the parabola is the same as either the min or the max, depending on the direction of the parabola, and they can be found from this expression, which is the standard form. They can be found from the standard form, and that's why the standard form is helpful. That's it for this video. We're going to look at another example in the next video. and then consider things in general, and look at some modeling examples in the future videos. Okay, thank you.